Hi everyone, welcome to this video where we will learn how to do the auto scaling on AWS. So before we begin with today's video, let me give a quick introduction about myself. I'm Aishwarya Sood, working as a lead coach in the AWS domain at Ethnos. I have more than 2 years of experience in the training, delivery and development, and I am 3x AWS certified, Amazon authorized instructor and AWS Academy accredited educator. You can connect with me on LinkedIn. My profile name is given here. Also, you can scan this QR code to view my profile. So let's quickly begin with today's video. Let me tell you what we are gonna cover today. So we will discuss a little bit about elasticity and the need for scaling with a few examples, and then we will see how to do the auto scaling on AWS. We will learn different strategies for it and the types of scaling that can be done. Also different components that are involved in the entire process of auto scaling, and then we will see how we configure actually the auto scaling on AWS console. So let's first understand the need for auto scaling. Here I have taken the example of auto scaling need at a restaurant. Okay, suppose that in a restaurant there is a waiter that is assigned to work at the register. When the coffee shop is in a period of low demand, the barista can readily manage their workload. Now, suppose that the coffee shop is open during its busiest season of the year. Because of the increased demand, the waiter feels overwhelmed by the increased workload because there are more customers coming up and it is becoming difficult for him alone to take care of all the customers. The waiter asks the manager for additional assistance and the manager assigns another waitress to help. When the workload decreases, the second waitress that have come up can stop working at the register. This process is an example of manual scaling. So scalability basically involves beginning with only the resources that you need and designing your architecture to scale automatically in and out in response to changing demands. As a result, you pay only for the resources that you are actually using. You don't have to worry about the lack of computing capacity to meet your customers' needs. Now, what if you want the scaling to happen automatically? So the AWS service that provides this functionality for Amazon EC2 instances is Amazon EC2 Auto Scaling. Let's have another look at what does elasticity mean. Elastic in general terms means the ability of something to expand and contract. Similar thing we are talking in the cloud computing terms. We want to achieve elasticity, basically scaling up and down. So let's have a look at this example here. For a workload, the predicted demand is this. The pink dashed line, this depicts the predicted demand. In a traditional IT procurement model, that is a traditional IT infrastructure when the data centers are on premises, to cope with this increase in demand, businesses would need to regularly invest upfront in the large purchase of the infrastructure. They would continue to use this infrastructure until more capacity was needed and another large investment was made. So this much of infrastructure has been purchased based on the prediction that this will be the demand. Now the actual demand is this. This means a big opportunity cost exists for the businesses that have invested in high levels of infrastructure that aren't utilized at all when the demand is low. Consider how these upfront costs could have been reallocated if these demand patterns were known. Because when the demand is just this much, we still have this much of hardware, but this is getting wasted here. Now another thing, have a look at this one. Here the lost opportunity is there. Because here the workload was more, the people wanted to access something, but because of the lack of infrastructure, they are getting a negative experience. So this will for sure lead to a negative end user experience. You can consider a familiar example like or a familiar feeling like, let's say website has been crashed when you were trying to purchase some newly released tickets for a popular movie. So that time only you wanted the first show, okay, and that time while booking only the website has crashed. So that kind of feeling here. Here the cost was getting wasted, but here the in this case the user is getting negative experience. Now here comes a cloud. Here we are getting the elastic cloud resources, because cloud lets us fit the supply to demand through the elastic cloud resources. Because unlike the traditional infrastructure, we don't need to provision resources months in advance when we are working on the cloud computing. We don't need to keep the resources that are not used, and we don't need to even worry nearly as much about inability to meet the forecast customer demand. As and when the resources are needed, we are getting it, and when they are not needed, we are just deleting them. So you can have a look. When this was a peak, we had this much of resources. When the peak went down, the workload was low, we had just this much of resources. So similarly for the all other peaks as well, just whatever we are needing, we are just having that. No lost opportunity, no cost wastage, nothing at all. So elasticity basically is the ability that we want to achieve for our architecture, and scaling is a technique that we will be using to achieve it. There are two types of auto scaling on AWS that we can do: AWS auto scaling and Amazon EC2 auto scaling. AWS auto scaling provides application scaling for multiple resources such as Amazon EC2, DynamoDB, Aurora, and many more across multiple services in short intervals. Amazon EC2 auto scaling helps you ensure that you have the correct number of EC2 instances available to handle the load of your application. So in today's video, we will cover both of these types of auto scaling. Let's start with the EC2 auto scaling. Now think about another situation where you tried to access a website but it wouldn't load and it kept timing out. That's because the website might have been receiving more requests than it was able to handle. This is similar to the experience of waiting in a long line at a coffee shop when there is only one barista present to take the orders from the customers. EC2 auto scaling can help you automatically add or remove the Amazon EC2 instances in response to the changing application demand. And by automatically scaling your instances in and out as needed, you can maintain a greater sense of application availability. Like you can see in this diagram, on Sunday, this was the provisioned capacity, the gray one, and this was the used capacity. On Monday, it was more needed, so we provisioned more, and this much was used. So it is just sufficient. It is not more, it is not less, it is just sufficient. That is what we want to achieve, and that is what we achieve through the EC2 auto scaling. There are different scaling policies and types that you can choose to configure. For example, dynamic scaling, scheduled scaling, and predictive scaling. There are other components to configure as well. For example, the launch templates, auto scaling groups, etc. So we will learn about all of this in the upcoming slides. Before we proceed further, let me tell you about the ways, like the types of scaling that can be done. One is horizontal scaling and one is vertical scaling. Horizontal scaling works like this. Let's say in the current base configuration, we just have two EC2 instances that belong to an auto scaling group. And when we perform a scale out action, there are now three EC2 instances, okay, with the similar configurations as the previous ones. And when we perform a scale in action, that means we are terminating an EC2 instances. Now again, we just have two EC2 instances as the base configuration. This is a horizontal scaling, when we are scaling in the horizontal direction. Another can be vertical scaling, when we are not adding the number of resources, but we are adding the capacity to the same EC2 instance. Let's say I have this EC2 instance which is of T2.micro capacity. Okay, its EC2 instance type is T2.micro. So when I vertically scale, which means I am scaling it up, I am changing its size from T2.micro to T2.x large. This can happen. Another thing, when I want to scale down, maybe from T2.x large, I am bringing it back to T2.micro. This is when I am adding or removing the capacity of the same instance. I am not adding more resources. This is vertical scaling. Now we have different ways to scale with the EC2 auto scaling, which includes scheduled, dynamic, and predictive. Let's discuss about them. Scheduled scaling can be used for the predictable workloads, like let's say every day at 12 p.m. you need some more EC2 instances because you know that the traffic is predictable, and every day at 12 p.m. more traffic is going to come. So I can set a scheduled scaling policy where every day at 12 p.m. two EC2 instances are getting launched. Okay, so that is a scheduled, when specific time I know that I want the scaling to be done at that time. Dynamic you can use for general scaling requirements, when you want to do the scaling based on a CloudWatch metric or something, like let's say based on the CPU utilization I want to scale. I see when the CPU utilization is more, maybe it is beyond 60%, launch some EC2 instances. When it is below 30%, terminate some EC2 instances. So something like this, if I want to do, I can do with the dynamic scaling. Then comes the predictive scaling. where the capacity scales based on the predicted demand. It uses machine learning, and predictive scaling uses the data that is collected from the actual EC2 usage, and the data is further informed by billions of data points that are drawn from the observations by AWS. And AWS then uses well-trained machine learning models to predict your expected traffic and the Amazon EC2 usage also, including the daily and weekly patterns. So the model needs at least 1 day of historical data to start making the predictions, and it is re-evaluated every 24 hours to create a forecast for the next 48 hours. And the prediction process produces a scaling plan that can drive one or more groups of automatically scaled EC2 instances. Moreover, dynamic scaling and predictive scaling can be used together to scale your infrastructure even faster. The EC2 autoscaling group or the EC2 autoscaling helps you ensure that you have the correct number of EC2 instances available to handle the load for your application. So you create collections of EC2 instances, which is known as the autoscaling group, which is nothing but a logical group of the EC2 instances on which the scaling actions will be happening, whether the scale out, scale in, it will be happening on these EC2 instances only. Other EC2s that are existing in your account but are not a part of the autoscaling group, nothing will happen to them. We can specify the minimum number of instances in each autoscaling group, and Amazon autoscaling, EC2 autoscaling helps ensure that your group never goes below this size. You can specify the maximum number of instances in each autoscaling group, and the autoscaling will ensure that your group never goes above this size. Okay, and if you specify the desired capacity either when you create the group or at any time after you create it, EC2 autoscaling helps ensure that your group has this many resources. Also, please note that the desired capacity is a trigger based setting and can fluctuate in response to events like threshold being breached. Okay, and it also reflects the number of instances that are running at that point of time. It can never be lower than the minimum value or greater than the maximum value. So minimum capacity and maximum capacity is a required one. Desired capacity, it's up to you. You can or you can define it, or you cannot define it. It's entirely up to you. Minimum capacity, let's say you set to 2, and maximum you set to 5. So no matter whatever is the condition, it will never go below 2, it will never go beyond 5. Okay, even if there's a need. So accordingly, you can set these things. Desired capacity is more for the manual scaling. So I will show you this in the demo. Now, how do we invoke the EC2 scaling with different events? Let's have a look at that. We can invoke it with the health status checks. We can configure our group to maintain a specified number of running instances at all the times. If an instance becomes unhealthy, the group terminates the unhealthy instance and launches another instance to replace it. Then there can be CloudWatch alarms. A scaling policy will instruct the auto-scaling to track a specific CloudWatch metric. It defines what action to take when the associated CloudWatch alarm is in the alarm state. And there can be SQS queues which can scale our group in response to the changes in the system load in an Amazon SQS queue. Then there can be schedules. We can scale by schedule also. Actions are performed automatically as a function of time and date, like how I explained you the scheduled based scaling. Then there can be manual scaling. It is the most basic way to scale your resources. Specify only the change in the maximum, minimum or desired capacity of your group. Amazon EC2 autoscaling will manage the process of creating or terminating the instances to maintain the updated capacity. So we just have to change the capacity numbers in these minimum, maximum and desired, and this autoscaling will take care of the further things. So when you work with autoscaling, what components do you encounter? First will be the launch configuration and launch templates, which will define what resources do you need. Okay, like what security group to be used, what key pair to be used, what instance type, MIID and all. Then EC2 autoscaling group, where and how many instances do you need, and when and for how long do you need them will be defined by the autoscaling policy. So let's first discuss about the launch configuration and the launch templates. A launch template provides full functionality for the EC2 autoscaling and also newer features of the Amazon EC2, such as the current generation of the EBS provisioned IOPS volumes, EBS volume tagging, T2 unlimited instances, elastic inference, and dedicated host. It is recommended to create auto-scaling groups from the launch templates to ensure that you are getting the latest feature for the Amazon EC2. A launch configuration is also an option, which is nothing but a template that an auto-scaling group uses to launch the EC2 instances. When you create a launch configuration, you must specify the information about the EC2 instances to launch, which include the AMI, that is Amazon Machine Image, instance type, key pair, security group, IAM roles also if needed. And alternatively, you can create the launch configuration using the attributes from a running EC2 instance also. A launch configuration will specify this EC2 instance configuration. But defining a launch template instead of a launch configuration lets you have multiple versions of a template. Okay, so this is a preferred way of using with the auto scaling groups, because another benefit of this was that you will be able to get the latest features of the Amazon EC2 if you use a launch templates. Now, apart from this, another component will be the auto scaling group, which I just told you is nothing but a logical group of EC2 instances on which the scaling actions will be happening, which will define where and how many instances do you need. We will define that in which VPC and which subnet to be used, which load balancer if needed, which one to be used, and also these capacities also will be defined with the auto scaling group itself. Apart from this, there will be the policy that we will be defining, which will tell when and for how long do you need them. Scheduled policy, on demand, predictive, which is on demand is like we have dynamic also, manual also, scale out policy if we need scale in policy, and what kind of strategy we want to use. Everything we will be defining here in the auto scaling policy. So all of this we will be seeing in a quick demo where I will show you how to set up the auto scaling for EC2 instances from scratch with the dynamic scaling policies. So let's quickly go to the AWS console and let's go to the EC2. What I'll do is I'll just quickly launch one EC2 instance and then we will attach to the auto scaling group, and then we will set up the auto scaling policies. So first and foremost, the EC2 instance needs to be created. Let's go ahead and quickly launch an EC2 instance. Let me name it as first EC2, and AMI, we are okay with the Linux to AMI, and then t2.micro is also okay. Key pair, let me select. So let me create a new key pair itself. Let me name it as AS demo. Okay, so, and we need .ppk because we will be using with the putty. So the key pair has been created. I have downloaded it, and network settings, let it be the default VPC and all the other things. Now what I'll be needing in terms of security groups, yes, I'll be needing the SSH traffic because I'll be connecting to my EC2 instance through SSH. Okay, so this let it be this one. No other rules are needed as of now. Storage also let it be default, and no advanced details needs to be changed because I don't need anything else from here. I'll just quickly launch an EC2 instance. So my EC2 instance seems to be launched. Let me view it. Once it is ready, we can start working on it. So now what I will do, I will add this EC2 instance into an auto scaling group. I don't have any auto scaling group, but I'll be adding it. So actions, instance settings, and attach to the auto scaling group. I'll be creating a new auto scaling group by just typing the name of it. When I type a name, it will create a new auto scaling group. Okay, if there is any existing, then you will see in the list. You can check that. Otherwise, you can create a new. So I have now created a new auto scaling group, and I am going to attach my EC2 instance into this group. So let me show you the auto scaling group and the launch configuration. So we didn't create any launch configuration, but it has already taken one. So where does that launch configuration come from? This is created with all the default values that we have given for our first EC2 instance. All the same values it has taken for the first launch configuration that has been created. You can create a new launch template, you can create a new launch configuration, that is up to you. Right now for this launch configuration, all the values for the first EC2 like AMI, instance type and all, the same things have been taken for this as well. Here if we see the auto scaling groups, let me open and show it to you. The capacities are there. Here we can set it up. Activities here, we can check out all the activity history from here. Like let's say this is the first activity, an instance was added in response to user request, keeping the capacity at the new one. Okay, this is the activity when we attached our EC2 instance to our auto scaling group. So we add the dynamic scaling policies here, we add the predictive scaling policies here, scheduled actions also here. Here is where we can add all the scaling policies. So let's first change the capacities here. We will change it and I will show you the effect of it, like the manual scaling. How do we do? Minimum capacity, let me set it to 2, and maximum capacity let me set it to 4, and desired capacity let me set it to 3 right now. Okay, so I will update it, and once it is updated we will go back. So now we will see the effect here. Within the next few seconds we will be able to see the new instances, because we have changed the desired capacity to 3 now, and soon we will be having few new instances here. Let me remove the running from here and let's see. You can see these are the 2 instances that are getting launched. These are into the pending state as of now, but these are the 2 that are getting launched because we just changed the desired capacity to 3. So let me show you in the activity also. See this pre in service, because we changed the desired capacity, that's why now the 2 more EC2 instances are getting launched. So desired capacity basically is this is what is the effect is. Manually we can scale, okay, whatever number we specify. This means that this many EC2 instances we need right now in our AWS account. So this is the effect of it. Now you can see, let me just filter it to running and show you the EC2s that are there because of this now. 1 second. Yeah, you can see 3 EC2s we have now. This is all because of the desired capacity. If I changed it to 1, it will become 1. So let me show that as well. I will change the desired capacity to 1, but no, that will not be 1 because minimum capacity we have set to 2. So let me just make it to 1 as well. Okay, because otherwise it would not have been able to go below that. So now I have kept it 1. Now let me see, refresh, and within the next few seconds 2 of the EC2s will start getting terminated. So let's keep refreshing it. You can see only 1 EC2 is running now and the other are getting shutting down. Let me show you this, and this EC2 instance is getting shutting down now. So we just have 1 EC2 instance that is running, that is this particular EC2 instance. No, so now let me name it as the second EC2. Okay, now this was about manual scaling, but we want to see that how the auto scaling can be set, how we can do the automatic scaling. For that you can set all the policies here. We will be creating a dynamic scaling policy. When we go to dynamic scaling policy, we have 3 kinds of scaling here: simple scaling, step scaling, and the target tracking scaling. So let's first discuss about simple scaling. Simple scaling is like, let's say you want to set, like, if CPU utilization is greater than 70%, launch 1 EC2 instance. Okay, just this much. You can't do anything else here. When you go to step scaling, it is like, let's say you want to say, if CPU is greater than 70%, launch 1 EC2. If CPU is less than 40%, decrease 1 EC2. Similarly, you can add steps here. That's why it is step scaling. So simple scaling also has the same settings. You can see step scaling also has the same settings. Only difference is that we have the add step option here. So step scaling policy we will create, and another policy we will be having for another thing is target tracking. This is like when we don't want to do much efforts. Okay, you can see we just have to specify a metric type. Okay, now right now it is CPU utilization, so I'll go ahead with that only. and target value we have to specify something whatever we want. So it is set as 50. Let it be 30 or something, or just to see the effect of scaling we will keep it to 30. Okay, and instances need dash seconds warm up before including in metric. So this is the number of seconds which you want your instances to wait before getting into action, before getting included into work or in metric. We want 0 seconds. We don't want that our instances should warm up. As and when the EC2 is launched, immediately it should get into action. It should be included in the metric. So this policy we will create, and I will create another policy to show you the effect of that as well. This we will create for scale out only. I can check here so that this disables a scale in to create only a scale out. Yes, that's what I want. But this policy can do both scale in and scale out also. It's just up to you. Since right now I want to demonstrate both the policies, that's why I'm keeping this for scale out. Another I will create for the scale in. So this policy has been created. Now what it will do? It will scale out, which means it will create one more EC2 instance when the CPU utilization goes beyond 30%. I will create another scaling policy, the step scaling, which we will name as step policy. One second. And for this we need to create a CloudWatch alarm as well, because I don't have any CloudWatch alarm as of now. So I will go ahead and create a CloudWatch alarm, and in that we will also choose the CPU utilization metric itself. Okay, so let's create a alarm. Before that we have to select a metric. I will search by the name of auto scaling group, which is demo ASG. So we have got here, let me check. Yeah, here we will go and we'll choose the CPU utilization metric. Let's find where it is. Yeah, you can see here it is. So this is a metric that we need to choose, and then we will go ahead and select the metric. Now what time period should be set, what threshold should be set? Let's decide that. When the CPU utilization is lower than, let's say, 10% for 1 minute only, we will keep. Okay, then we will decrease the number of an EC2 instance. So we will add it as remove. Okay, so this alarm is there. Now next thing is notification. When your alarm is into the alarm state or OK state or anything, do you want to get a notification? Then you can specify these settings also, but for this demo I don't want it, so I'm just removing it. Okay, and I will go ahead. Then I will give this alarm a name. I will give it as step alarm, and then next, review all the settings and create the alarm. So we have the alarm ready. You can see there is another alarm, target tracking also, but this is not the one that I created. I just created step alarm. Target tracking got created automatically when I created the target tracking policy, because in that I don't have to do much efforts. Now here we go. CloudWatch alarm we will set. Let me refresh here and select the step alarm. Take what action should be taken when this alarm is in the alarm condition. Remove one EC2 instance. Okay, remove one EC2 instance when CPU utilization is less than 10. So we will create it. I can add more steps as long as it is valid. If we compare it with the previous steps, we can keep adding the steps. But right now we will be just adding one step. So we have two policies now. Step policy for the scale in when the CPU goes below 10, and target tracking for scale out when the CPU goes beyond 30. Okay, so both the policies we have, but we have to see the effect of it. We will be able to see the effect of it only when the CPU utilization goes beyond 30. Right now, what is the CPU utilization? Let me show you. This is just 0.24. That's it. So how it will go beyond 30? It is not going beyond 30 unless and until we put some load on it. We are not using this EC2 instances, so the load can't go beyond 30, right? It can't even go beyond 10. So how it will go beyond 30? So for that, what we will do, we will put some artificial load on our EC2 instance, and we'll see the effect of the scaling policies. For that, what I'll do, I'll just connect to my EC2 instance through PuTTY. Let me just open PuTTY. and we will connect to this EC2 instance. Let me take the IP address of it and give it here. Session time we will keep to at least 400 seconds. Let's select the key that we have created, which was ES demo. Okay, so we will open it, and here we go, log into our EC2 instance. So here we go, we have logged into our EC2 instance. Now what I will do, I will install a repository and a package called stress in order to put the artificial load onto it. In order to just simulate the CPU load on my EC2 instance, I'll be doing that. So for that, let me run a command. Okay, so just for installing this repository. From this itself, we will be installing a package known as stress. So this is getting installed and now it is done. Now let's install the stress package. Here we go. This is also almost done. Now this is complete. Now let me run this stress command. I will put the CPU load onto it and we will run it for at least 300 seconds so that it keeps running and we will be able to see the full effect of the scaling policies, because it will be scaling out when it goes beyond 30 for 3 data points within 3 minutes. Okay, otherwise it will not work. And the other policy also we have set for 1 minute. That's why some particular time period I have set. So we refresh it and we will keep seeing how far this CPU utilization go. Right now it is still 0.13 only. Okay, so we just have to wait for some more seconds to see how far it is going. So let me pause the video here and we will. So you can see now the CPU utilization is going beyond our specified particular value, and now you can see it is 42.6, which means our scale out should start happening now. Okay, let me see if any instances are launched as of now, or it is yet to. So right now it is not, but soon it will start launching few EC2 instances. Let me just refresh the history from here. Right now it is not. Yeah, you can see it is already in service. So it is in service. It is launching the EC2 instance. Okay, changing the desired capacity from 1 to 2 because of the target tracking demo, because we have created it for the scale out policy. So these instances will be getting launched now because the CPU has gone high. Soon, this is just one instance. You can see more instances will be getting launched. Okay, first this gets launched and it will be displayed here. You can see another instance has come up. This is the one that is getting launched because of the target tracking. Now this is getting launched automatically. I didn't launch it, but this is all coming automatically. Now as long as it is there, it is CPU utilization is high, the target tracking policy will be into action unless and until the maximum capacity is reached. Okay, if there's a need for that. Okay, so it will launch the instances. So if it stays like this for the another time also, it will launch another instance. Otherwise, if it comes back, then no other instance will be launched. So we have to wait for a few more seconds to see the effect. I will keep refreshing it and let's see. Yeah, one more EC2 instance is getting launched. So this, you can see, this is all happening because of the target tracking policy that we have created, because it is launching the new EC2 instances because of the increase in the CPU utilization, because we have put the artificial load on our EC2 instance. Now this is done. The scale out is happening. Once the CPU utilization comes back to this level, it will start terminating the EC2 instances, like how we see how we have seen with the previous one, when we did the manual scaling with the desired capacity, how it started terminating the instances when the desired capacity was changed. So similarly, when the CPU utilization goes from 42 to another, like let's say what is this person, 0.13, when it comes back to this, then the step scaling will start its action, which we have created for the scale in actions. Now this will not stop for the next 5 minutes at least. Okay, this will keep running, but once it goes back, then we will be able to see. So let me see if something else is happening. Yes, third instance is also getting launched. Now we would have more EC2s here. Yes, 3 we are already having, 1 more is getting launched. So we will be able to see that also very soon here. And let me now see CPU utilization still here. So yeah, the EC2s are getting launched here. So this is how the policies do work. Okay, the scale out and scale in happens automatically based on the policies that we have set. You can use this auto scaling for different use cases of yours. You have now the idea how to set this up. Now this can be used for different requirements. You can set the scheduled scaling policies, dynamic also, like how we have seen, or predictive also. So I hope you have understood this demo. Now we will go back to our slides and finish today's session and with the last topic for today. So let's cover the AWS auto scaling now. So far we have been discussing about EC2 auto scaling, that we can increase or decrease the number of EC2s with the EC2 auto scaling. We can also use the EC2 auto scaling with the AWS auto scaling to perform the predictive scaling. Because using AWS auto scaling, we can set up the application scaling for multiple resources and not just the EC2 instances. If you specify scaling policies, then AWS auto scaling can launch or terminate the instances as demand on your application increases or decreases. Also, it integrates with the ELB. So you can attach one or more load balancers to your existing auto scaling group, and after you attach the load balancer, whatever new instances are getting launched by it, it will automatically register it with the load balancer. You won't have to do it manually. Also, it is a separate service that monitors your applications and adjusts the capacity to maintain steady, predictable performance at the lowest possible cost. The service provides a simple and powerful user interface that will enable you to build the scaling plans for the resources, not just EC2s, but EC2 instances, spot fleets, Aurora, replicas, DynamoDB tables and indexes, and even the ECS tasks. If you are already using EC2 auto scaling, you can now use it with the AWS auto scaling to scale additional resources for the other AWS services. Even we can optimize a cost, availability, or a balance of both when we are using AWS auto scaling, because it automatically creates all the scaling policies and sets the targets for you based on your preference. So that's all for today's session. I hope you have understood all about auto scaling, and now we will meet in the next video. Thank you.